No? Is it working yet? Wow, it's the very beginning of the morning. It just happens to be 10:13, and I'm definitely talking about this for the first time. And it's crazy because every video before this I have fucked up and I've not recorded the sound. So here we are. Let's start over, but let's do a brief rundown. This is the Swift Style Guide from raywenderlich.com. Ray Wenderlich is a great source for tutorials on Swift stuff and on iOS stuff. So when I say Swift, I mean the precise programming language that we learned all the fundamentals about last week and then the month prior to that. When I say iOS, I mean building apps for iPhones. So we know that Swift works on multiple platforms. You've built Mac OS apps before. Now we are working specifically on iOS apps, things for your phone and maybe an iPad if you really, really feel like it. This right here, this guide, you can use to structure all of that code because you're going to be writing your iOS apps in Swift. So when you see iOS, when you look for a style guide for iOS, chances are you want a style guide that's written in Swift. Ray Wenderlich has a whole bunch of writers for their site, and because they have a whole bunch of writers through trial and error, they put together this guide as a way to stay consistent through all their tutorials, all their videos, a way for them to present code in a way that is the same each time regardless of who writes there. That's the same reason that other software companies have a style guide, because they want all the code to kind of look the same so that everyone can work with it. Kind of makes sense. So this should be, for now, a guide to all of you. There are no rules about how you write your code, but there are guides that people who've coded a lot more than me and probably you have put together based on what they've seen in the past and what worked for them. You can trust that. So let's take a look. We've got a table of contents. It says something about correctness. Let's see what that is. Correctness. Strive to make your code compile without warnings. This rule informs many style decisions such as using selector types instead of string literals. We'll see more about selectors, I think, tomorrow. But take this message to heart. I think you might have started to see as you've been running your apps, they do give you red stop sign warnings, and that means it can't compile. But they also started giving you these orange triangular cone warnings saying you might not want to do this. When they say strive to make your code compile without warnings, they mean try to write your code in such a way that you don't have those triangular warnings. As you learn more and more, obviously you're going to learn about different ways to code and how to avoid those warnings. But keep that in mind when you are writing your code. So try not to have any warnings, because maybe it's not the best way to do that. And you can definitely learn more about the best way to do it. I think sometimes they offer you a fix on how to make it better, just like with a big red stop sign. So that's good. So that's correctness, which is super important. We've talked a little bit about naming, but basically they're saying if you name things in the way that we tell you to do all these different things, then it'll probably be easier for you and other people to read your code. Code organization. Ooh, protocol conformance. What is that? Are we going to learn about that today? I think so. Cool. Protocol conformance. In particular, when adding protocol conformance to a model, prefer adding a separate extension for the protocol methods. Okay. This keeps the related methods grouped together within the protocol and can simplify instruction to add a protocol to a class with its associated methods. Excuse me. Interesting. Okay. So I see some stuff. We can come back to this at the end of the day. But it's saying, it's kind of, if you take a look at it, you might not know what this means yet, and we're going to talk about it in just a tiny bit. It looks a little bit like inheritance, right? And you see that this thing, this class called myViewController, seems to be inheriting 3 different things all at once. But in their preferred way, they have it inheriting 3 different times. What principle does that seem like it fits? Separation of responsibilities. So here, they've broken out their code into 3 different parts so that it'll be able to tell you What will it be able to tell you? You'll be able to look to each part, look at the specific methods that it's getting from each of these extensions, which I know it's very exciting. We'll be talking much more about, but just visually, it breaks these things down in a much more readable way. Cool, protocol conformance. I can't wait to learn more about that today. There's also plenty of code organization about unused code. I think what they mean is don't have unused code, probably. That's probably the highest level thing. And then there's a whole bunch more stuff that you can learn about how they say to do stuff. You can probably learn a lot about closure expressions from their style. Let's take a quick look, because I know closures are so exciting. So they say it's preferred that you might use a closure in this trailing closure syntax. So where it's not fed as an argument in a function call, but rather where after the function call you define the closure as its own thing. It also says it's okay to use closures within a function call, but it seems like this is only because it's a much more complicated closure. Let's see what they say not to do. Yeah, so this closure right here, the closure, in this function right here, is the same as the closure in this one, but it's much more readable to use that trailing closure syntax. So instead of adding an argument, they instead of using a trailing closure, they have an argument here that is a closure, and it starts to get cluttered within the function call. So that's probably much easier to see. I'll let you parse through this one as well. Also looks pretty damn tough to use, just because of all the clutter. So, wonderful. Let's see what else they have to say. For single expression closures where the context is clear, use implicit returns. Cool. So we could have put a return statement right before this line to say we're returning A is greater than B. We could have also put a return type as a bool, but we don't need to because this is a pretty clear closure. What you're doing is comparing A to B. You're seeing if A is greater than B. When you do a comparison, what type do you get back, Michelle? You get a bool back. That's awesome. So we don't really need to give all that information. We can trust other programmers that they'll understand what a comparison gives you in the end. There's plenty more to learn. It's so exciting. Look at all this stuff that you can do. I think what they're trying to say is strive to make it readable. So think about if what you're writing is readable, show it to someone else and see if they can read it. It'll help you organize your code better and better. You will thank yourself later for starting to use these principles today. Cool. It looks like there's a whole bunch of stuff here. Great. We're going to learn a whole bunch of stuff. Not all today, but we're going to learn a whole bunch of things in the future. And you can probably refer to this Swift style guide from Ray Wenderlich for all of it. Syntactic sugar. Do you want to learn about syntactic sugar? Okay. Doesn't it sound nice? So syntactic sugar, prefer the shortcut method versions of type declarations over the full generics syntax. This looks nice and readable. More so than this, syntactic sugar just means that they've created a simpler way to do the same thing. So syntactic sugar is usually this array of string type annotation is built upon this type annotation for arrays of strings. They do the same thing, but they built into the language that it'll be easier if you just declare it like that. In the same way that you can always declare an optional of a type using the keyword optional, but if you know the syntactic sugar with that question mark, it's a much easier way to do it. It's much more readable, they've done you some favors there. So there's syntactic sugar is not just the Swift thing, it's in every language. It's like, hey, we noticed that the old way of doing it was really annoying. Here's a better way to do it. So that's our style guide. Does anyone like it? Does anyone have any issues with it? Okay, great. It is a really, really good set of guidelines. I wonder what my voice sounds like on this recording. I'm self-conscious. What's that? Okay, so let's talk about a few things. Okay, so tomorrow morning, you're going to have available to you the first week-long project. So rather than asking you to do a project over a weekend, it's just kind of a pain in the ass, especially for people who might be working on the weekend or have childcare on the weekend or, have a real life. What we're gonna do is assign on Friday to be due on the following Thursday a week-long project. That week-long project should only involve skills that you've learned this week. So for the project that starts tomorrow, you should only need stuff that you've learned this week. You should be able to do it. There's nothing new, but there's a longer timeline than with your command line applications, which, those were tough. Let's see what tomorrow's is actually. Let's pull up Canvas. Look at all these classes I get to be part of. Today's August 1st, isn't that right? Okay, so tomorrow, Unit 2, Week 1 project, begin. It's tic-tac-toe, cool. So I just made a note here. It's a calendar event to give you the project and tell you when it starts, but you'll be submitting through something on next Thursday when it's due. Tic-tac-toe, player v. player. There's some instructions. Ayula can definitely tell you how you can make a pull request back to our repo from your fork. By the end of the day, Ayula will be able to tell you how to do it after he and I review it. Okay. And then tomorrow, he's going to lead the class. No, just kidding. So for this assignment, you'll be bringing tic-tac-toe to life. That's all I'm going to go over right now. But now you know what it is. It's tic-tac-toe. Think about how that might work. We can talk a tiny bit more about how to code it tomorrow. What are some questions? How do you think you're going to make this app? With what operating system? So Swift is the language. iOS? Yeah, that sounds good. So you're going to make an iOS app. You're not going to make a command line app, which is going to be great because you can build the UI in Interface Builder. So that's going to be awesome. What are some other questions before we really get rolling with some code? Say that again? Yeah. We're going to make, I think I said this Tuesday, so we're still working it out. I know I say we're still working it out a lot, but what I want to do is, going forward, that 5:30 review, we'll try to do something from the lab or a key skill from the lab or just some kind of coding exercise together. So today's lab is, today's lab is much more like Unit 1 labs where you really work on a whole problem set of fundamentals about protocols, but you will like it, I promise. And so maybe we'll work on a problem at 5:30. Then the next day, which is today is the next lecture, you could say after Tuesday's lab, we'll do a simplified version of that lab. So on Tuesday morning, Sunny created a flashlight app that was similar to the more complex lab from the day before, using some of those skills. This morning, we're going to make a mini MVC app, and then we're going to get into protocols. So I want that to be the pattern going forward. And again, hold me to that. So if I'm not doing it, just be like, we didn't do it. So that's the pattern going forward. We're gonna, short answer, yes. We're gonna review the labs, but not in full. Where's some more questions? Okay, so what should we make this morning? I want to practice the MVC pattern. So your apps had a view that changed color randomly, and then the user had to guess what color was the dominant color in there. Someone explain what we meant by dominant color? Kimball. Cool. So what are the three colors? Awesome. So it was just a guessing game where the user had to decide, okay, I see something, it might be orangish, it might be pinkish, it might be perfectly red, it might be blue. Which of the RGB values is the highest, just visually? And so you had to do a whole bunch of things. What I want to do is I want to make the view there, I want to make the controller that controls the view, and then I want to just make a struct that's the model for our RGB values. I think once we make those three layers, adding the buttons is much easier. So we're just going to add one button that changes the value without the guessing game. How's that sound? Cool, let's make it. All right, and also what we're going to start to do in class, which I hope you will all start to do with your labs, is we are going to, sorry, my brain's off. We're going to start to use good Git hygiene. I'm going to commit my changes as we make them. And I would insist that you all do the same on your labs. Don't just commit at the end. Don't just say, lab done, git push. Instead, break it down into chunks as you complete some work. So let's do that in class as we are doing that in our labs. I'm going to open this new lab on my screen. What should we call it? Color changer, single view color changer app. Okay. Put it on my desktop. Just give me a second, I'll drag it over. Okay, come on, come on. Come on over. Okay, I created an app called Single View Color Changer. What a beautiful name. I'm gonna make it a little bigger. Before I do anything, and you won't have to do this if you are forking labs, but I think it's important to keep seeing it over and over because you might have to do it when you create your own files later on. I'm gonna clear this all out. I'm going to change directory, cd, back to the root. I'm going to ls, I'm going to list everything there. I'm going to go into desktop, so I'm cd desktop, change directory to desktop. Can you see this in the back, Kevin? Okay, great. Now I'm on my desktop. I see that my single view color changer app is a folder here. So I'm going to change directories into there. It's going to be a great day for noise. Great. So I see all the stuff that's in Xcode. I also see this configuration file called Xcode proj. That's great. So my files are here. If I check git status, you've probably seen this a bunch of times. Fatal, not a git repository, .git. What that means is this is not yet initialized as a git repository, just a folder you created. So to initialize, you just type git init. You hit enter. Now, when you check git status, it just says all the stuff in here hasn't been added to our file, hasn't been added to our git log. If we check our git log, it says fatal, your current branch master does not have any commits yet. So I initialized my git repository. I need to add a first commit to get my git log started. So to start recording what my work is, I'm going to git add. If I hit dot, that adds everything in the current directory. So it's going to add all of these files, which are actually, yeah, they're actually folders. It's going to add all these folders. So git add dot git has now added everything to staging. It's ready to be committed, so let's see the difference. Whoa, all these are changes to be committed. They're all green, which means that if I commit something with a message, so git commit, create app, I don't know, workspace, and now we're off the screen. It's going to create a new commit. Great. I'm not going to add this to GitHub yet. But right now, I can record all of my changes locally using Git. If I check my Git log, it's going to say I have one commit, and it's the commit that I called create app workspace. It's got a date, tells me who the author is. It's got this key or identifier, which don't really need right now, so that's fine. All right, I've initialized my workspace. Now I'm going to go to Xcode and start coding. But at certain points, I'm going to stop coding and make sure that I've saved my changes so that if I need to backtrack, I can know where things went right and where things went wrong. All right, so I'm going to move launch screen and app delegate away. Come on. Come on. I'm going to put them in their own folder. I'm going to call this something else. Supporting files. Great. Let's check my Git status. Whoa. New file. This supporting files. Whoa. Something was modified. The Xcode project settings of my project. And then it says that those files, app delegate and launch screen, were deleted. When you move files around in the hierarchy of your folders, Git's going to think that you deleted the old ones and created new ones. So visually it looked like we just moved them, but in the way that Git's going to track them, it's going to say there's a new file in this location, and that file that used to be in the other location, oh, that's weird, it's gone now. It doesn't mean it's actually gone, it just means that you moved it, and that's something I could commit. I could say created my supporting files folder and moved the app delegate and the launch screen storyboard file into there. So I'm going to git add all that stuff as well. So git add dot. Now I'm going to check my Git status. Cool, that stuff is all in there. Now it said, oh, I saw a new file, and it looked like you deleted the old file. But really what that means, because I'm smart enough to figure it out, is you moved it. You renamed its location. So if you see the old name points with an arrow to the new name. So the old name is gone, and the new name is the thing after the arrow. That's the thing that we just created in Xcode in this supporting files folder. So let's look at the structure. We've got the name of the project, single, view, color, change app. Then supporting files is the folder name, and then the actual file name. So that's all this rename means. It means that you moved it. Maybe you might rename a file later on. That's fine. But when you create a folder or you move files within the hierarchy, it's also going to treat that as renaming them. So let's commit this now. Git commit. I'm going to say moves, launch screen, and where is it? App delegate, thank you very much, into supporting files folder. Great. So if I look at my Git log, it's telling me a whole bunch of stuff. First, I created my app workspace. Then I moved my launch screen and app delegate into supporting files folder. There is a best practice for your Git commits as well. Start with a present tense verb. Say, this is what this commit does. So this commit I already did wrong. It should have said something like creates app workspace. It makes it easier for someone else to just read through your thinking if you start with a present tense verb. So start as if you are explaining it to someone to their face. What did this commit do? Or sorry, what does this commit do? Oh, it moves the launch screen and the app delegate into supporting files folder. It's a great explanation. Thank you so much, David. You're welcome. Great. So let's go back. Let's create some views. Sunny. Git init will initialize a new repo in that folder that you're in. It's not going to create a repo on GitHub. So we have to do that separately later. But it's going to start tracking Git locally on your computer. So when you've been forking and cloning, you've been cloning something that's already initialized from a certain location. All right, so our app is going to have a view and a button. How do I get those? Eric. I want to start with a view. Eric over here. Then Eric over there. Let's start with Eric W. So I want to start with the view, and this is going to be the view where we're going to assign a random background color. Let's just use a regular view. How's that? So if I go to my objects library, I can get just a UI view from down here. I'm going to just drag it out. Come on there, fella. I'm going to center it. Great. So what we're going to do here is somehow, using some information that's controlled by something else, I'm going to be able to change the color of this view. That's great. Now, Eric M, I want a button. How can I get my button? Command-Shift-L to open up the objects library, search button, get my button, drag my button out here. Great, sounds great. I'm going to give these like gray background colors so that we can see them. Come on. Beep. There we go. Where you at? Oh boy. What's going on? Does anyone notice what I'm doing? Let's see if that helps. Cool. Where was I just before? So I was in my launch screen, which is not the storyboard file we want to be using. So check this out. Let's check my Git status now. Isn't this fun? So if I check my Git status, I see it changed a whole bunch of stuff. It changed my storyboard, and it changed something in the settings folder called Xcode user state. I don't want these changes. I want them gone. Instead of deleting them from Xcode, what I can do is I can hit git checkout dot. This dot again means everything in the current folder. So git checkout, what it's going to do is it's going to discard my changes. Look at that. It gives you directions. Change is not staged for commit. So you haven't hit git add yet. If you use git checkout, it'll discard those changes. And I just press that dot to say, I want all of the changes gone. So that's great. Let's check. Yeah, they're gone forever. I could just delete them in Xcode. But what you might see is this Xcode proj folder is hard to revert to its previous state because it's not something you directly control. So maybe I just want to tell it I'm done with you altogether and check out everything in it. Let's see if that works. Great. So I checked out a specific location this time.
What's the difference between that and just the dot?
So dot tries to check everything out. I honestly don't really know much about how this Xcode proj works, except that it's a pain in the ass. So sometimes you might have to go ahead and check it out itself.
Okay.
I'll get you more information on exactly what it does, but right now it's like doing the behind the scenes stuff of making sure that it's storing settings in many, many different ways, both in like how your app works and how storyboards should be interpreted and a lot of different things. So I wanted to get rid of all of those things. Let's go back. If I look at my supporting files, And I go to my launch screen. It's going to load it. Okay. Now I'll see that there are no, if I open up this view controller, in the outermost view, there are no subviews. There's no button. Good. That's gone. See you later. Now I'm going to get out of my launch screen. I'm going to go to my main.storyboard. I'm sorry, Eric and Eric, for not taking your advice before, but I will add a button. Then I'm going to change the background color here. I'm going to make the color of that button just like a light gray. Doesn't look like looks like it's too light. How's that? Light gray. What should the button say? Let's say press me. Sounds good. I'm going to just center it so I've got that line right down the middle. I'm going to change the text color. So I've got this right here. And remember, again, these are all properties of a button, which is inheriting from a control, which is inheriting from a view. It's a lot of inheritance going on there, and we're going to talk about maybe another way to do that today. So press me. I'm going to go with that. All right, now I'm going to add that view that Eric said to add. We go all the way down, find just a regular old UI view, center it. I'm going to set its background to be light gray just because it'll make it easier to see. And if our app works right, it'll start updating immediately. But I just want to see it as gray in my storyboard. This is just the thing that I want to do. Helps me work. You don't have to do it. Great. So we've done some things right now. We've added 2 views, and these are going to be the only views we need. So I'm going to commit those changes. Let's check my git status. Cool. That settings thing changed, and my storyboard changed. I'm going to git add all that. I'm going to git commit. This adds view and button to view controller. Great. If I check git status, there is nothing to commit. It added all those changes. If I check my git log, I've got a good running log of the things I've been doing. Great. Let's go back. I want to show you something else, an Xcode specific thing. If you look at the files on the left side, if I change something in storyboard, so let's say I move this, and then I start doing something else, maybe like I add another view, then I go to another file, do the thing I want you to do. All right, maybe it's easier from a Swift file. So let's say print something. We're not going to keep this, but I want you to see what's happening. If you look at, I know it's hard to see in the back probably, but if you look at the icon for that file, you're going to see it's grayed out. That means that it's been changed since your last commit. Git is hooked into your project here. So Xcode is able to keep up with your Git repo. It's able to keep up with all the changes in it. It's going to say that it was modified. That's what that M means. And it's going to say, and then if it's grayed out, it also means there's some kind of change going on there. So visually, without even going to your command line, this is a good way to see what you might need to commit. If I Control Z and get rid of all those changes, you're going to see that it's not grayed out anymore. Great. I'm going to Control Z my storyboard here. That's great. I love it. Sometimes these letters take a little while to update, but you can always look at the icons changes. All right, I've got my views. What can I do next? Well, it makes sense. Sam, what can I do next? I've got all my views. Let's think about MVC. So what this app is going to do is this view is going to have a random RGB value. And then this button is just going to change it. We're not going to have the guessing game from yesterday. We're just going to have the actions from yesterday. Cool. So let's make a new model file. How do I do that? File, new file. Awesome. So I'll make sure it's a Swift file. Make sure it's in this same folder. Sounds good. Hit create. Now I go in there. Awesome. So what kind of model do you want to make? What's this struct going to do? Handle the color changing. Awesome. What do you want to call it? Color change. Sounds good. Do you mind if I ask you to make the one that you've got, or ask you to tell me about the one you've got? Yeah. Green, blue. All right. CG float, CG float, and CG float equal to 0.0. All right. That equal to 0.0, and that equal to 0.0. Var alpha equal to 1. Just going to make it 1.0. What is this type CG float? Did you figure anything out about it? Cool. So it's just another type of decimal. We've been using doubles a lot in Swift. In order to initialize a UI color, we're going to need a different type of decimal type. So if you remember, there were different types of ints, different types of decimals. We've generally used ints and decimals. Now we're going to have to get used to using different types for each of those number types. Sorry. Because when you initialize a UI color, you don't use a double, you use a CG float. I'm seeing some errors on the side here. Nima, can you help Sam out here? Great. So I think it's not recognizing what a CG float is. How can we make it recognize that? Okay. So I can change this import foundation to import UIKit. And what that's going to do is it's going to import a different set of functionality. It's going to import, specifically for our purposes, CG float or cgloat, CG float. We need that CG float. Maybe we need it for a UI color later. So this is just a set of functionality that seems like it handles stuff that happens in the UI. We can also have multiple import statements. So we could also have kept that import foundation. If you notice when I'm typing it, it says it's a module. Just think of a module as a set of functionality that you are bringing into your code. Phoenix, is that call for me?
Why is it default to import foundation? Why can have everything that foundation has already?
Because a Swift file by default wants to work just in like kind of the fundamental Swift types. So foundation imports most of that. It doesn't, when you create a new Swift file, it doesn't know that its purpose is going to be to work on UI. So by default, it's just like, let me get arrays, let me get dictionaries, let me get doubles. And then UIKit is bringing in a specific type of decimal that tends to only be used in UI. Cool. Sam, let's keep going. A mutating function, mix color. Okay, cool. It's going to return a UI color. Color. Awesome. Equals CG float dot random parens 0 dot 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 1. Awesome. So what's this doing? I'm going to spare you the rest. It'll do the same for green and blue, I assume. Awesome. So green, blue, great. So we're picking 3 random values between 0 and 1 as a CG float. Now we want to maybe make a UI color. Okay. Alpha. Okay, so alpha is equal to 1. Let my color UI color. Cool. So we're initializing a new UI color. Which initialization did you use? Maybe this one? Okay. Cool. Great. Blue. And alpha is equal to alpha, right? Cool. Awesome. Return my color. Great. So is this what your color change does? Awesome. So now we have a model. Mind if I try to explain the model? I know you're the expert, but I'm going to try. Okay. So what our model does here is its job is to create a UI color for us. So when we initialize one of these, we will have some properties available. It's going to mix those colors. Sounds good. We're going to get what we need. Maybe we could refine this later, but it's going to work the way that we want it to do. It's going to give us exactly what we need. So we've got a model. Love it. What should we do now? It's a trick question. We're not going to code. We're going to do something different. Tia. I don't want to do that yet. I'm going to commit my changes. So I just did something. I created a whole new model that does some stuff. And now if I wanted to go back and see what I did, if I commit it right now, so I'm going to check my git status, I'm going to see that there's a new file. Great. I named it file. So I'm going to go back before I commit it. I'm going to change the name of that file to colorchange.swift. So now that color change.swift file explains to someone who doesn't know what's in there. Seems helpful, right? Pretty good thing to do rather than call it file.swift. So let's check our git status again. It's going to say there's a new file called colorchange.swift. Great, sounds good to me. Then it's going to say all this crap. For now, I'm going to say you can just commit all of that. Sounds good. So I'm going to add all of it. If I check my git status now, all right, there's all those changes to the project, to the settings, and then also my new file color change. So if I haven't committed a new file yet, it's going to commit everything in that file. I won't have the opportunity to look through that file. So because I have a new file called colorchange.swift, and it's got some code in it, when I commit this, it's going to commit both a new file and all the stuff in it. Anthony.
So if it's something to be saved, I have to go back to the previous.
Great question. We will do that. I'll make sure we do that. If I don't do that, yell at me. Cool. So I'm going to commit this. I'm going to say creates color change model. Boom. Now if I look at my Git log, see I did a whole bunch of stuff. I made it. I moved my files around. I added a view and a button to the... That wasn't a great name. I should have said that I added my view and my button to the storyboard. So that might not be helpful to someone later on. My bad. Then creates color change model. That's what we just did. Great. So we've got our view, we've got our model. What connects them? There are 3 letters in MVC. We've used 2 of them. Kevin, what's the one we need now? Thank you very much. So we need our controller. So we have this struct called color change to work with. Let's go to our view controller. Let's actually go to our storyboard and use our assistant. I'm going to get rid of this document outline thingy. How can we connect our views to our view controller? And vice versa. Levi.
Do the Spider-Man thing.
Do this. Okay, shoot a web. I get it. Great. Create some outlets and some actions. So I'm going to create an outlet from my view. So I'm going to say, this is really good. I love it. I'm going to say, this is called random color view. And this outlet means that I can find a way to send updates to my view from my view controller. So that's the direction that outlets work in. I want my view to tell me when it has some interaction with my button, though. How can I do the Spider-Man thing for that? What are we going to call the specific type of Spider-Man thing for that? Crystal. Yeah, so I've got an outlet, which is a way that my view controller can tell my view something to do, right? So that's an outlet, is going from the view controller to the view. I want my button, which is a view, to tell my view controller stuff. So I had an outlet to the view. What is the thing that I would get from my button? Awesome. So let's make an IB action from my button to my view controller. Let's call this, I don't know, button pressed. I'm not feeling very creative today. Before I hit connect, I should make sure that I've clicked the connection action. So when you do the Spider-Man thing from from a button in the UI, it's going to give you the opportunity to create an outlet and an action. So make sure that you've specified which one you want. I'm going to hit connect, and now I'm going to say B. Did you have a question?
So when you create the ID outlet, I saw that it had weak and strong. What's the difference between weak and strong?
We're going to talk about that tomorrow when we talk about lifecycle. It's a specific, it's saying when this variable is instantiated. So your outlet has to link to your view controller. And I'm sure plenty of you saw this yesterday, maybe when you named the outlet in Storyboard something different from the outlet in your view controller. This tries to account for a certain situation in the life cycle of your app. So when it's launched, when the view controller comes and shows, when it maybe goes away, which we'll learn about. It tries to account for all of that by storing this variable in a specific state. I know that's super vague, but we're going to do it tomorrow. Yeah. Okay, we've got an IB action.
Why do you type in any of those ones instead of button?
I shouldn't have done that. So I'm going to Control Z a couple times. I'm going to right click on this button to make sure that, oh, look, there's still a button pressed sender there. Interesting. Can I just re-drag it? I can. That's great. I'm feeling so much safer now. So even though my action Let me do it again, yeah. So I just deleted the action from my view controller. And maybe the UI is not updating. All right, it looks like the dot for that action is still there. So it looks like it's still trying to link my view controller to the view in my storyboard. But here's the thing. Again, yesterday you might have seen if things are named something different in your storyboard and in your view controller, your app's going to crash when it attempts to load. Right now, there's an action named button pressed in my view controller, and there's a reference to an action here that has no name. So it's not going to work at all. So it's going to crash. So I can right-click on my button. I can look through these sent events. For now, just think of them as actions. So I see that there is a sent event called button pressed. I can link it back here. I can call it the same thing that it's called in the storyboard. I can change the type and make sure it's a button in case I want to do any button-specific stuff. I can connect it. And now, my app will not crash because this action, which is linked to this button, is also called the same thing as that sent event in my storyboard. So raise your hand if your app crashed because you got some kind of thing that said like it's not key value compliant. Like your app is trying to load and then it gives you a big red like yeah, SIGBART. It went to something called the app delegate. It gave you a big red line. It cried. It said, this is not going to work. And then down here in your output, you might have seen a big, long message. When you see that big, long message, you know what? Let's just make this crash and talk about that message. So I'm going to run it now. We're not quite there. We're almost done. And then I want to complete this before we take a break, so we'll take an equivalently long break. I see Liana doing the I need a break phase. You can do that. You don't need permission. You should go pee. Okay. So it's still launching. La-di-da-di-da.
So is it, when the argument was any, can't just delete any UI?
It's a good question. We can try it. It didn't crash. Now I'm angry. Okay.
Push the button, see if
I saw Ben do it, so I think you can do it. Okay. So if the names are mismatched, how about that? Crash. Do it. Come on. I'm scared though. Okay. I was scared. It says it's running. What? No, it's that's good because then you learn how to deal with it. So it goes to something called app delegate. That's that app delegate file that we put into our supporting files because we don't want to learn about it right now. But what this does is it starts the whole application. See this function application? It's saying start an app. So literally launch the thing. Then there's some stuff about the state that the app is in. That's cool. They tell you a whole bunch about what those do. I'm not going to tell you about those right now. So I see this big red line. It says thread 1, sig abort. Signal abort probably. I don't know. Doesn't matter to me. If I look in my output, let's see if I can make it bigger. I see all this stuff. So at the bottom it says terminating with uncaught exception of type NS exception. If you remember from yesterday, Ben showed you something called a fatal error. So it's something built into the code that causes the code to crash if it doesn't work right. NS exception is something similar where you haven't said, you haven't, think about it like kind of like an optional conceptually. You haven't told the app that something might not work right. And so it's saying, I totally didn't expect this to work wrong. I'm just going to crash. So an exception, an uncaught exception, is saying that something didn't work the right way and you didn't tell me how to catch that difficult situation. If I look at this, I don't really care about it. This is the stack trace of the error. You can totally Google what a stack trace is. But it's just saying, when I'm executing my code, these are the various levels at which it doesn't work. So I start from core foundation, which is probably similar to that foundation thing we've seen before. And then if I keep tracing like all the way through the code, then eventually I'll see that, oh, it crashed. That sucks. If I go above that trace, it's going to tell me more descriptive information. It's going to say, unrecognized selector sent to instance. So you could probably check Ray Wenderlich and see what he says about selectors. But what they meant is, when I tap this button, when I tried to select that button, I tried to use something of a name, maybe called button pressed, that didn't match anything in the instance of my view controller. So I pressed the button, but I didn't know how to respond to that. I didn't tell it how it might respond to it if it didn't know how to respond to it, so that exception was uncaught, then it crashed. I know this looks very scary. This is actually the single best resource in Xcode for figuring out what your code does. You should break your code. Do not be afraid to break your code. Making it work wrong is the first step to making it work right. We're talking about patterns so much these days. I want you to keep in mind something called red-green refactor. So red means thing's not working. Green means it works now. Refactor means go see if I can do it in a better way. That should be the process that you're working from whenever you do anything. Red-green refactor. If you don't know how to do it, try some stuff and see if you know how to do it. Great. All right, let's finish this up so that Liana can go pee. I'm going to stop the app because it's still running even though it broke. So I hit the square there. I'm going to go back to my storyboard. I'm going to make sure that this file loaded the correct corresponding file. I'm going to change back the name. You all said that Ben changed the name of the sender, so let's trust him on that. So great. I'm going to commit these changes. I'm going to say I connected my views to the buttons. Then we're going to come my view to the view controller. Great. Git status. Git add dot git commit. As M connects view outlet and button action to view controller. Great. Okay, let's go back. Now I want to create an instance of my model that I just created. So let, no, it's going to need to be a var because it's a struct. Let color changer equal color change. Let's initialize a new one. Great. Every time the button is pressed, I'm going to say, let's say random color view dot background color is equal to color change dot, and then this beautiful method that we created. Oh no, sorry, it's called color changer. So I tried to use a type method, but what I needed was an instance method, and I keep doing it wrong. Let's make sure I do it right. Color changer dot mix color. Great. So this is going to provide back to us a UI color. Great. So this is an instance of color change that has a specific set of random colors. And then to make sure that the color is changed for the next instance, what I'm also going to do here is I'm going to say color changer is equal to color change. So I'm going to initialize a new one. Actually, I don't even have to do that, do I? Nope. Great. So color changer, because the way we set up our struct, it's going to generate those random numbers every time I call the function. I don't need to create a new one. I don't need to create a new struct with these values reset, because those values are only set when I call this function. So there might have been a different way to do this. I kind of love how it works right now because it's super simple. So great. Now I did those changes. I'm going to check my git status. I am not going to commit this yet because I don't know that it works. So I'm going to run it, because if I say I added some stuff to my button and it doesn't work, well then what was the point of committing some broken code? So let's go back to our simulator. Great. Press the button. Great. Chooses some different colors. Seems to work. Great. Liana, you can go now. Git status, git add everything, git commit. Sets up color change action, sets up color change in view controller. Great. Cool. All right, so after our break, we'll do what Anthony wanted to know how to do. But let's take like an 8-minute break. Do 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 do.
Express like the specifics about it?
Probably have this dish though.
Because I know when I was like in a similar situation, I would give them like a list, like this thing can help the big plant, this can help the big neck, this can help you know what I mean? Like I would give them like very specific things. Okay. How much is your household income this much? Okay, you can apply for this. Here, go do it. I'm sure the font are hard.
I don't think I found.
I'm just saying, like,
Let's go. Inspectable. Yeah. Ooh. Can't wait to show you. So, you might be able to learn a little more about what that ABLE means today. Okay. Okay. Let's get started again. Let's finish this up. So we've got all our changes committed. Awesome. Anthony, what do you want to do now? Isn't it the thing you wanted to do? Oh. Ooh. On the GitHub repository. Mhm. Oh. Yeah. Let's do it in the command line here. Let's start with my handy friend, google.com. What are some search terms we can use? How to roll back. So, do you want to roll it back or do you want to just see what happened? Okay, cool. How to roll back to get previous commit. How to roll back to previous git commit. Sounds good. If you want to, I don't like that one. If you want to test the previous commit, just do git checkout. No. If you want to do git revert the last commit, just do git revert. Let's see if they can tell us how to do two. So on a site called Code Like a Girl. It's actually a really good site. How to undo the last commit. In this post, I will show you how I sometimes recover wrong changes using git on the command line. Why would I want to do this? I trust you. I get why you might want to do it. I would love to in just a sec. Okay, so to test a specific commit that you think has the last working version, you can do git checkout, and that will bring you to that commit. Great. That'll make the working repository match the state of this exact commit. After you do, you'll get the following output. You are in a detached head state. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches. If you want to create a new branch to retain commits you create, you may do so by using -b, which I think you've all seen this before. Great. Head just means where your Git history is pointing. So head right now points at your current situation. It's after your last commit, before your current commit. When you change head to this detached head state, head is now going to be at this commit that you rolled back to. And then you can make some changes. After you analyze the specific commit, if you then decide to stay in that commit state, you can undo the last commit. How to undo? If you wish to undo, revert the last commit, you can do the following using the commit hash that you get from the git log command. So let's see what that is. It's probably that big long thing. Cool. So let's say we want to revert to the previous commit. Let's try what they said. Git checkout commit hash. Cool. So I'm going to hit Q to get out of there and say git checkout, and then I'll just paste in the value that I copied from here. Hit enter. Okay, you're in a detached head state. Great. You can look around, make experimental changes, and commit them, and you can discard any commits you want. Same message we just saw. Great. So now we're just looking at that. We haven't made any changes. We're just looking at it. So if I check out my git status, it's going to say head detached at, and then show me a shorthand version of that hash thing, which is just like the first 7 characters, it looks like. I'm going to head detached at, and then this value for the commit that my head is looking at. If I look at my git log, now the last commit I see is the commit that I rolled back to. Great. Now, let's see what it said to do. How to undo this commit. Git revert commit hash. This command will create a new commit with the revert word in the beginning of the message. After this, if you check your repository status, you'll notice that you have the head detached at the commit we tested before. Great. You don't want to see this message. So, to fix this and attach back the head to your working repository, you should check out the branch you're working on. Oh, they found a tutorial. Great. So let's see if this git revert does what we want it to do. Let's get the hash value, which is this. Git status, head detached, git revert. Boom. Error. Your local changes to the following files would be overwritten by merge. Please commit your changes or stash them before you merge. Aborting. Fatal. Revert failed. Okay, so I have some unstaged and uncommitted changes here that it's not going to let me change my position until I handle those. So if I do git checkout dot, gets rid of all my changes again. So nothing to commit, working tree clean, and I'll do git revert. Great. Revert. Connects view outlet and button action to view controller. All right. I'm in this thingy called Vim again, which is just a text editor that works in terminal. If you need to get out of this, you can hit colon, which brings you down here, and you can start typing. If I hit this colon, and then if I hit Q, it's going to quit out. You could also have changed the text in line, but you might want to learn more about what Vim does before you do that. So I'm going to hit enter. So it reverted. Let's check our git log now. So we now have a commit that says it reverted that commit that we were looking at. So we lost all changes after that commit. We reverted back 2 commits. And then we reverted back the changes in that commit as well. Cool. Yes. Thank you. Cool. All right. So that, some MVC stuff. Rod. Can you undo a revert? I'll let you try that. I don't think you should need to use revert very much because you can always just correct that code and create a new commit. Say it needed to be changed, but not changed exactly back, which I think you'll see much more often. Just make a new commit. Are there any other questions? Okay, so I'm going to put our app to the side. I'm going to say goodbye, app. And then instead's not the right word. Goodbye, MVC app. Goodbye, that. Today, we're going to learn about protocols. Are you all ready? So, we have talked in the past about, I guess I'll just start typing this stuff up. I'm going to create a new project that is another app. No, you know what? Let's create a playground. Sorry. So I'm going to create a playground. I'm going to call this Lecture81am. I'm going to move this code over. Okay. So, yes. That's